Hello everyone, my name is Ms. Zhira. I'm a science teacher at Lezan Private Basic School. Today we are going to talk about new things, new terms, new chapters called temperatures. We're using this term a lot, but we don't know what's the temperature. But in general, we will using two terms instead this term. We said hot or cold. In here, we will start with what's the temperatures. We have a definition in general, say a measure of how hot or cold. But hot or cold, this is two terms, not scientific terms. We have a special definition for the temperature, a measure of the average kinetic energy. It means when you want to talk about temperature, should we know what's the kinetic energy? Should we go to the average kinetic energy for these particles when you know what's the temperatures? This is definition using for temperatures. Now we have a thing is between them should we know what's the relationship between them. But in general, all matter around us made of the particles and molecules. When particles collide with each other, collide with the wall, making kinetic energy. So when particles are moving fast, they have more kinetic energy. When we have more kinetic energy, we have high temperature. This is relationship between this is terms, this is characteristics, it will be directly relationship. When you say particles are moving, when moving fast, we have more kinetic energy. When we have more kinetic energy, it means we have a high temperature. This is relationship between this characteristics, it will be directly between them. When you want to fast particle moving, we have a more kinetic energy and high temperature. When you want to understand this is relationship, look at this is two picture we have. We have a picture number 1 and picture number 2. If you look at picture number 1, you see the same particle between them. But what's the difference between them? In the first one, we have the slowly motion between the particles. It means the colliding with each other, but slowly. When you have a slowly, it means we have a few kinetic energy and few temperatures, not high temperatures. And here, when you look at the picture number 2, you see the more it means fast moving between them, and we have a more kinetic energy and we have high temperatures. So this is temperatures depending for the kinetic energy and after depending for the moving particles. When you say today is so hot, why is today so hot? Because the particles colliding with each other so fast. So will be kinetic energy a lot, so you say the temperature today will be high. This is temperatures. So if you touch it or if you know by your imaginary what's the temperatures, no. Should we know what device or what's the machine using to measure temperatures? We have a lot of the kind of the machine instrument using for each thing is different. For example, we have anemometer and galvanometer, barometers. Now we have thermometer. Thermometer, this is an instrument, this is machine measuring to temperatures. How measuring to the temperatures? Thermometer, it's like a tool. We have a thin glasses, and inside that they have a liquid, maybe mercury, maybe cool. Inside the thermometer, this is device measuring two temperatures. After that, there are three scales using. We have a three scales temperatures. We have a Kelvin and Celsius and Fahrenheit. Celsius divided by two ranges between boiling point and freezing point. And also divided by 100 parts, equal 100 parts called degree Celsius. But if you look at the Kelvin, we don't have a degree Kelvin. We have only Kelvin. And also we have a degree Fahrenheit. If you look at them, we have a 0 Kelvin and minus 273 and minus 459. This is called absolute zero. When in here we have a 0 Kelvin, this is range, this is scale called absolute zero. What means absolute zero? Absolute zero, it means that this is temperatures when the particles inside that they have a minimum kinetic energy. It means in the absolute zero, the particles they have a minimum kinetic energy. After that, in the upper we have 100. So 100 in the Celsius is called when you boiling waters. So this is absolute zero. This is boiling point, okay? This is range between, this is scales using to measure temperature. There are three scale difference. After that, in here, so this is part too much important because in here changing the scale. For example, in the exam, we have a question depending for this is 4 rules, change from degree Celsius to Fahrenheit Celsius to degree Celsius. What's the difference between them? Same things, but only they have one difference. We have one difference. So Celsius change it to Fahrenheit. The rules say we need a temperature Fahrenheit. So 9/5 temperatures measuring by Celsius plus 32. But in the down, Fahrenheit changed to Celsius degree. Temperature by Celsius 9/5 T by Fahrenheit minus 32. It means we have one difference in here. In the up plus 32, in the down minus 32. If you want, didn't confusing in the exam, only memorizing one of them because in the another one opposite the first one. After that, Celsius changed to Kelvin. T measured by Kelvin, T measured by Celsius plus 273. In the down, like them, they have a minus. In here plus, in here minus. Only memorizing one of the rules didn't confusing in the exam. Look at this question. The question in the exam, the teachers bring for you like that. What's temperatures on the Celsius scale? It means needed TC is equivalent to 373 Kelvin. It means we have TK, how much? 373. But needed what? TC. So you're searching about TC. It means changing scale from TK to TC. Which one? TK from TC. You're searching about that. K, change it to Celsius. This is rule you write down in the exam. Say TC equal TK minus 273. How much TK we have? 373. How much in the rule? 273. If you calculated them, it equal 100 by what? Needed what? By Celsius degree. That's enough. In the exam, all of the question, maybe by multiple choice, by solving the question like that. That's enough for today. Wish you all the best for you. Inshallah, see you. Have a nice time.